In this section, we're going to continue to look at measures of central tendency, like the mean, median, and the mode, but we're going to expand on that a little bit. So for example, we have a table here that shows the NHL point leaders for the 85-86 season and for the 2010-2011 season, and the points that they have. So question A wants us to determine the range, the mode, the median, and the mean for each season separately. So range is a new term that we didn't see in the first section. And the range of data is just the difference between the largest value and the smallest value. So let's have a look at this. So for range, in the 85-86 season, well, the highest value is 215, and the lowest value is 116. So all we need to do is subtract those to find that the range is 99. For the 2010-2011 season, the highest point scorer scored 104 points versus the lowest point scorer, which was 85. So the range for that season would be 19. Okay? So that's what range is. It's just the difference between the highest value in a data set and the lowest value. To find the mode, remember, is the most common value that's there. So the one that appears the most. But if you look at both data sets, there are no repetition in point values in either data set. So there are no numbers that appear more than once. So for either data set, there is no mode for both the 85-86 season and for the 2010-2011 season because no values repeat. For the median, remember, we have to arrange the values from least to greatest and find the middle value. Luckily, they're already arranged for us, I believe, yes. So we don't have to arrange them. So for the 85-86 season, if I look at the values, what I like to do sometimes to find the median is cross out the highest and lowest and keep going down until I find the middle. And so the median for the first season is 131. And for the second season, which is 2010-2011, we can do the same thing. And we get that the median is 94. And the last thing we need to find for part A is the mean. I don't know why I'm putting B, C, and D here. We're still in part A. So let's find the mean for each of the terms. So, or each of the seasons, sorry. So 1985 to 86. So we just need to add up all the values and then divide by 7 because there are 7 of them. So if we add up all the values in the 85-86 season, we would get 986 divided by 7, which would give us that the mean is 140.8. If we do the 2010-2011 season and we add up all the values, we get 657, and there are 7 values, so the mean would be 93.8. Okay? So that's part A. So we found the range, which is just the difference between the upper and lower values in a data set. We said there was no mode because none of the values were repeated. The median is the middle value, and for the first data set, it was 131, and the second data set, it was 94. And the means, we add them up and divide them by 7, which is the number of pieces or data set, or the number of data in the data set. And we got that the mean for the first season was 140.8, and the second season was 93.8. The B part says, which values appear to be an outlier in the 2 seasons? So an outlier is a value that's much smaller or larger than the other data values. So it doesn't fit with the other data values. Some data sets have no outliers, and some data sets have a bunch of them. So if you look at all the pieces of data here, you can see that in the 85-86 season, Wayne Gretzky had 215 points. That is definitely an outlier. The next highest person was 141 points, which is quite a bit lower, over 70 points lower. So that's a great deal of a difference when some of the other values are, not even 5 points apart. And in the later seasons, some of them are only 1 point apart. So a difference of 70-some points is a great difference. So I would definitely call that an outlier. It doesn't really fit with the rest of the information. So what that does is it causes the data, when we do these measures of central tendency and we look for things like the mean, it causes a great deal of discrepancy. So for part B, we are going to call 215 an outlier. Okay, so part C wants us to remove the highest and lowest values for each season to find the trimmed mean. So what is a trimmed mean? A trimmed mean is a calculation of a mean found by removing the highest and lowest values. You must remove the same number of values from the top and bottom of a data set. Removing the outliers can result in a more accurate mean. So here's the thing, with a trimmed mean, let's say my numbers are 1, 1, 2, 3, and 15. So 15 is definitely an outlier. And what a trimmed mean does is it says remove that outlier and find the mean without it to get a more accurate vision. But I can't just move 15. That kind of unbalances my data set. I have to remove it from both sides. And then if I have a data set, let's say it's 1, 2, 2, 3, 20, and 25. And I recognize that there are 2 outliers. 20 and 25 are both outliers. Well, I can remove both of them, but again, I have to keep my data set balanced and remove them from the bottom as well. So I can remove as many outliers as I want, as long as I keep my data set balanced and remove from the other side. So this one says remove the highest and lowest. So if I want to remove Gretzky, I also have to remove Savard. And it says to both data sets. I don't really see an outlier in the other data set, but we're going to keep them as equal as possible. So we're going to remove Sedin and Ovechkin. And then we're going to go ahead and find what we call the trimmed mean. And we're going to compare them to the means we found in part A, which I'm just going to jot down because we've moved over to a clean sheet. So in part A, in the 85-86 season, the regular mean was 140.8. And in the 2010-2011 season, the mean was 93.8. So we're going to use those and compare them to our trim means and see what happened. So this is part C, trimmed mean. So to do that, to find the trim mean, we're going to add up these 5 values instead of the 7 of them, and then we divide by 5 because now we only have 5 values. So for the 85-86 season, if we add up that column, we get 655 divided by 5, and the new mean would be 131. For the 2010-2011 season, if we add up these 5 values, we get 468 divided by 5, and we get 93.6. Okay? So if we compare the data sets, the data set that had the outlier, the mean has changed quite a bit. It's changed by almost 9 points. Where the mean that didn't have the outlier didn't change by a whole lot. So you can see that the outlier greatly affected the mean, where in the other data set, there were no outliers, so the mean wasn't really, affected by those upper and lower values. So the next question is, did removing the higher or lower values affect the mode or the median? So it would not affect the median because you've kept the data set balanced and eliminated the same number of values from the top and the bottom. That central value will still stay the same. It may affect your mode in some cases if your mode is one of those higher or lower values, but in this case it didn't because we didn't have a mode. So it did not affect the median because we kept our data set balanced. So we eliminated the same number of upper values as lower values. This is not B, this is D. Sorry about that. It also didn't affect the mode, so I'll continue this over here. Did not affect the mode because we don't have one. But in other instances, it may, if the mode is one of those values I'm eliminating. So keep that in mind. The final question is, should the outlier be removed? Why or why not? So that's really a personal opinion, and it really depends on what type of information you're trying to get out there. So, for example, if the purpose was to make a statement about Wayne Gretzky's ability to shatter records and affect the overall averages, then of course you would keep that in there. But if you're trying to compare, average points between seasons, maybe eliminating those outliers gives you a more accurate look. So it's really a personal opinion on whether you remove the outliers or not, and it should be based on what kind of information you're trying to determine.